Nidden? Yeah, Nidden, what's up?
So we have to turn all Homer from 911 to...
I'm just collecting last week, actually. I'm just going to do week batches from now on. So I don't really even care about the beginning of the chapter homeworks. I'm just going to collect last week. So 914 through 931, essentially. Because 932 is kind of flexible depending on what if you were in class or not. Practice it to make sure you're comfortable with it, but it's just more analyzing of functions. So if you were in class on Friday, we looked at these 6 functions, and we were comparing them together. Right, now we're not going to spend a lot more time on this because, as we've talked about, we don't have enough time this year. We're running out of time. By the way, if I look weird, I have slept awkwardly on my neck and my back hurts. That is part of getting old. If you want to know the real, longer version of the story, I tried out a silk pillowcase because I'm dealing with my, face issues, breaking out, being allergic to stuff. And the silk has no friction. This is where math comes into play. So as my head rests on it, it scoots away, and then my neck got all weird. So the silk pillow ran away from me, and I ended up with no pillow, and now my back really hurts. Adulting sucks. So we looked. I'm missing a pen. We looked at these 6 functions, and I think you each divvied up. I'll take F, I'll take D. What did you guys find out about these? Who can try to kind of put these answers together? Thomas?
Well, I can say that with F, then 333, much less 1,000, you're calculating things to infinity.
Okay.
So
you said all the way back at 333, the calculator thinks it's infinity?
Yep.
So we're thinking F is the biggest?
Yes.
Okay, now what could we say strikes you about F compared to the other functions? And it might have a relationship with another, but how are these functions different? How can we categorize these functions? The different growth behaviors really. I mean, somebody other than Thomas, or we can let Thomas keep going.
There's exponential functions, there's linear functions,
Okay, so as we start to get towards the end of the year, and as we prep for your end of course exam, which we don't make a big deal about, but the test you take for the state is how you pass this class. Okay, so just make sure we all understand that. It's an EOC called an end of course exam, which for high school classes you must pass to get the credit for that class. No one's ever not passed, but one of the things they're going to look for you understanding out of this year is the different types of functions. So being able to go through and say, this is a linear function with a slope of 100. This is a quadratic equation or parabolic function with an intersection at 1,001. And what type of special function is it? Perfect square. So it has only shifted vertically. It has not shifted left or right. This is an exponential function, 1.1 raised to a power, when compared to this exponential function of 2 raised to the same power. This minus 1,000 does not really do very much.
It's not an exponential function.
And just another parabola with a different scalar on it. Yes.
So we took the high school test last year.
In the fall, you took EOC. Well, no, it depends on if you took it over the summer or, but either last spring or this fall, you took the EOC for Math 1. Yes.
Yeah.
It's when we do air and park and all those. That's your EOC. End of course. So it's the way that Ohio has simplified me giving an exam versus somebody else giving an exam, but for the final exams. Yeah, it's your final exam for the state.
You should have said that. No one's scared.
No one has ever not passed, and trust me, your guys' skills are above that of students I have previously seen pass the test.
Can I have some examples?
hey, I'm gonna go.
Yeah, you're good.
Help out with the move
Yeah.
and stuff, and I'll be back.
Good luck.
Okay, thanks.
Yep. So big thing here, and then we're moving on, is being able to compare these functions, put in input values, talk about growth. Then, and we're not really going to dig into this, we can look at when these functions trade places, and especially if you have an application like Desmos, you can see where those intersections are, and where the growth behavior of one is going to overtake the growth behavior of another. But like I said, we're not necessarily doing that today.
all we wanted to do was talk about the different types of functions, and then make sure you remember domain are input x values, and range is your output or y values.
Wasn't that last year? You know, I got that too many times.
The next 2 weeks are going to be a lot of, like, you should already know it, but I'm going to say it again anyways.
The entirety of
Questions from 9 through 10.
No.
So last week we were looking for average rate of change, and if we look at the technical definition here, it's the change in the y value divided by the change in the x value for 2 distinct points on a graph, which is the slope of the line through these 2 distinct points. So we talked with our parabolas about this average rate of change being an approximation, right? As you would get closer and closer and closer points, your approximation will get closer to the actual line behavior at that location. So when do we use exponential functions? When do we use exponential type functions? Thomas?
when something is speeding up.
Something is speeding up, or there's a situation we use exponentials for a lot that also you guys probably know because it's the name of a game.
Epidemic.
It's a game. I don't know.
So half-lives, right? When something is decaying, we
Why don't we write
What's
full
the
line?
name of the game?
so we can date artifacts and things that we find on the ground based off carbon dating, based off an exponential graph for its half-life decay, because carbon's pretty easy to look at and analyze. So just to wrap that up before we move on to piecewise type functions, exponentials are used for things when they're speeding up or slowing down. So like a half-life decay, you always get half of the previous amount. You never end up with nothing. Never end up with nothing.
So that's why it's called half-life.
So literally, the amount you start with, and it depends on what you're looking at, whether you're looking at carbon or other things, will half every time you go a certain time span.
They should release half-life.
Okay, off topic. So then, and you can go ahead and head your paper now, 933, we were talking about piecewise functions. This is normally when people have some confusion. Because most of you come into this thinking, oh yeah, piecewise, I've seen those. It's a step function.
That's where you're wrong.
Yeah, that's where you're right, but you're also wrong. So a nickname for this is step function. However, that's misleading because what a piecewise function actually is any function that breaks the outputs at certain inputs. So notice at the input of 0 here, I go from a linear behavior graph, I jump or take a step to a different place on my graph, and then my behavior completely changes.
What's the equation for that?
We'll get there. Patience, young Padawan.
I want to learn how to sword fight with light.
So, the Horizon Phone Company, avoiding trademark infringement, offers a basic monthly voice plan. You should care about this. Before you know it, you're going to be paying your own bills. Where customers pay a low monthly fee, but must pay extra if their calls exceed a certain number of minutes. Now, if
We
you...
don't use phone calls.
Right, but data, right? So in the 2019 version of this, if you exceed a certain amount of data usage, you then have to pay more. And it's not, you only pay more for each little megabyte you use. You pay for an entire another like couple gigs, and then you can use that. It's how cell phone companies operate.
Why would they do that?
Because they want to steal your money. Think about it. They're a company. They're not your BFF. They're your cell phone provider. So then you use your data. Once you hit that endpoint, pay for another couple gigs. Use it. Like, you're not going to incrementally pay a tiny bit more every tiny bit of data you use. No, they're going to rip you off. So, same thing with minutes, right? But think of minutes as data if you need to for your brain. So, here we had a monthly fee of $40. But as soon as we surpassed 450 minutes, now let's pause here for a moment. If I am on the phone and I am using minute 450, do I have to pay more than $40?
No.
No. It is in the exact moment that I go to minute 451, which is why we make this circle shaded and this circle open. It's shown at 450, I'm here. But then as soon as I'm off of that, because there's no actual way for us to nicely show it on our graph, as soon as I'm at 450 minutes, point anything, I jump to this line. Okay, so like, and this could be 20, 40, 100 digits out. It's anything over 450. This is where the jump happens. Now, the thing kids will try to screw up is which one's shaded, which one's open, and the fact that both can't be shaded unless there was some real weird situation going on. So,
like have to pay.
This is saying, right on my line straight, I think at least close. This is saying what? What can you infer from this graph? After 450 minutes, what? Okay, give me more details. How much money?
You pay another 50 cents every minute.
50 cents every single minute. Now, most plans probably wouldn't do that. They'd say, here's another 100 minutes.
But like
You owe us $5 or $50 or whatever that math will come out like. And they're just going to charge you lump sum all together. Luckily, this phone plan is going to charge you per minute, but it's still 50 cents a minute? Come on. That's a lot.
Well, not fucking for 450 hours a month. No one even called each other.
This is not 450 hours, it's 450 minutes. Not very many hours, really.
I don't.
Yeah, so how do we write this as an equation? So wait. What would our function, if we want to start to get used to function notation, how do we notate this function that we're trying to represent? So we're not going to use y equals anymore.
F of T.
So fancy.
Yeah, but ooh, I could use m since my input's actually minutes. And instead of using f, what could I use?
T of M?
Yeah, the output is the cost. So the cost at minutes, okay, it starts at 40, but then how do I'm going to let you guys talk about this for a minute. How do we express this as a function when we start at 40?
I feel like we're gonna have to use some like if with like then words.
Well, we're just writing an equation for one piece of the graph right
Oh, it'd just be the same.
now. It'd
Just be
y,
40.
y equals.
What if you allow yourself to
Not
write
C
it?
of M.
What if you allow yourself to write it as if it was linear, not piecewise step function?
But it's not linear.
I mean, start thinking somewhere. It has linear behavior. What are you frustrated about?
Cause like if it, can I go up on the board and explain it?
Sure.
Okay.
Yeah.
If it was linear, I feel like this part hurts my head. Thinking, right? Yeah.
The break in the graph. You
That's
just have to be
what's
okay with that.
Okay.
Ignore the break. Yeah, I mean, so this behavior right through here is linear. Ignore the break that we wouldn't. It's probably not proportional, right? It probably does not hit 0, 0. Most cell phone plans are probably not proportionally created. So we can't write this linearly, right? Because then we'll get a continuous line. So what we're frustrated by here are the steps, right? The jumps. So this is where piecewise and step has its difference. This specific type of piecewise function is a step function. So step functions are piecewise.
but any broken function is a piecewise function. Cool? I wanted to be really specific with that this year because we got into a bad habit of kids thinking any piecewise was called a step function. Step function is a special type of piecewise.
This is not
Like squares would be right.
Yeah, this is not.
Oh. Oh.
No.
So
Weird.
let's play with some notation. If you were to take what we have in 9103 and try to graph it, I'm gonna flip my screens around so I can have some graph paper. Oh no, you saved the square. We don't
Wait, can
need
you
the
graph
square.
that on this?
Well, no, let's just graph this using what we know. We have f of x is 3, or is -1, or is 5. Yeah.
Well, why does it have a 1? 1 would make equal in my brain.
From
Oh, that's how you draw it.
if we go to show f of x is 3 under the domain restriction of -4 to -2, where they both have the or equals, see that, right?
Yeah.
Then at -2, what do I do?
Nothing. Wait, less than 2, less than 2, less than 2.
I jump, right, or step to a different output of
-1.
-1. Is this circle open or shaded? Open, based off exactly what Satu was just saying, because it's just less than. And then that goes up to
Ew, I barely get it.
shaded circle.
This is not.
And then we jump to 5. Open. So, here's my issue that I have with
What does
this.
the 5 be colored?
This doesn't really make a lot of sense in our head. This is just practicing, can you take what they have written and put it on the graph? F of x is describing the output, and then it gives you any special conditions that you need, like domain restriction. So when f of x is 3 is between -4 and 2. We include those points because they both have the or equals. Then it jumps to an output of -1, open, and then shaded, and then it jumps to an output of 5. So does what we graphed make sense based off what they had written?
Well, that last point would be colored. What is the.
I did color in the last point.
Oh. What's the 5 be out? 1.
Yeah, you're absolutely right. I made this on 4, not 5.
Now you got
There we go. My bad. So, graph B. Now you actually have some behavior of the function. I'll pull it down here.
But that's
It's
supposed to be
2x
a
minus 5. I'll pull it down here.
But that's supposed to be a pun behavior.
No,
Oh, you put
it
an
wasn't.
accent on the B. Yeah, so it's because of the intention. Like a normal human being.
Yes.
Or go take a restroom break and don't come back.
See, I love that.
You boy,
How's it going,
look at
Hunter?
this,
Doing alright?
Hunter, right there.
I don't care if you use multiple sheets of paper. Your life's going to be way too hard trying to graph this on not graph paper.
I just steal a bunch of you about like a time and then put it on that.
Now, here's your trick. Even if it doesn't exist at that location, we can still grab it. We can still use it, and then we can get rid of it or erase it. So 2x minus 5, we know starts at minus 5. Or negative 5, if we're going to say that properly. And a slope of 2, we know...
Yeah, but you can't go that high.
Ah, so I'm not supposed to be going that direction, though. Because it's when x is less than 1, so go the other direction.
Wait, what? That's not how it works. Oh, no. I thought you meant like reflect it, and like you can't just do that. That's not your decision
So
to make.
all my points just shifted. I accidentally shifted my page. So down, still keeping that slope of 2. And if it's less than or equal to 1, does my point stay shaded, or do I have to make it empty?
Less than or equal to. Why do you erase those?
Because they're outside the domain.
Oh, that's a domain. Sorry.
Our domain restriction is that we have to be less than or equal to 1.
I thought that was range, so I stopped at 1.
Domain x values, right? So then we have x minus 3 squared plus 1 when x is greater than... Well, let's just figure out where the heck it is at 1. What's 1 minus 3?
What, 2?
Negative 2 squared plus 1. Okay, so this one we're going to graph at 5. And open circle, right?
Yep.
Now, a lot of times when I'm working with students on this, they're like, oh, this is so frustrating because now this is... Back yourself up. Just find out a couple values. So plug in x is 2. You don't have to actually derive the quadratic equation here. And negative 1 squared. 1 plus 1, 2. Okay, well that wasn't that bad. Do it again. Plug in 3.
It's not filled in.
Yes, because it's in the domain. So will every point between here and there be filled in once I know the behavior?
You put it tricky.
Not really.
You pulled a delusional on yourself.
So what was that Bob Ross thing like?
I don't know, but I'm up here. When x is 3, 3 minus 3 is... Okay, so that's just 1. Okay, sweet. When x is 4.
Oh, okay, that makes sense.
I see what's happening.
Oh, they gave us 5 and 5. It's
I know.
oh, I get that. Oh, that's kind of fun.
Now,
Well,
when
that's 2 lines.
these are actually used, any business, any company has varying functions that change over time and depending on what's happening. So, a company like a mom and pop shop that opens up has equations, whether they know them or not, they might just be inside their QuickBooks program or whatever, of how many employees they can have, how much they can spend on electricity, gas, rent, all that stuff, and how much stuff they sell. There's a certain magic number that lets them stay in business. But below that, in a certain domain range, you're closing down shop. Right? So these functions, this mathematical thinking, is all over the place. And the change in behavior, people don't think about it, but it's always happening because at that certain break-even point, now we're making profit. But now my equation changes to like, well, now how much profit and what can I do with it and where, so yeah, we can go really deep into this. Or you can look at the variable sales of as I increase price of something, my profit might go up. But then if my price increases to a certain point that people aren't buying it, then my profit takes a hit because I sell less. But if I sell less, but make more off each one, am I okay to sell less?
But then
Or how
why
much
don't you buy
more mathematical functions? This is where it all comes in.
it? People don't use
No one uses math.
My brother doesn't make a ton of money by doing math every day. Oh, wait, yes, he does. My brother-in-law is an accountant. He's doing the math stuff that makes you lots of money. And, you know, I'm here. Elissa is training to run a 5-mile fun run. That just seems oxymoronic to me. Fun run is not. They don't go together.
Why is it a 5-mile and not a 5K? Who does this?
Because we're Americans. All right, one day she runs.
So much cooler.
One day she runs from her house to her friend Anna's house, 2 miles away. Elisa talks to Anna for 10 minutes while she stretches, and then she runs home. So Elisa runs at a pace of 1 mile in 10 minutes, or 6 miles an hour. Right, on the way to Anna's house, and on the way home, she runs 1 mile in 12 minutes. Slightly slower, cooling down. Right? So draw an accurate graph of her distance from home relative to time. So the function we're creating here that we're going to end up wanting to be able to express with the mathematical terms is distance from home related to time, or minutes you could do. But yeah. So I would first maybe graph it and then try to write out the math. Or if you really think that you're feeling really comfortable, you can try to write out the math. But when we get to that end point, we will have domain restrictions and 3 different regions. We want distance from home relative to time.
It's like those things we did in science. That's what I was thinking, except slightly more complicated. Slightly more complicated. Walking away from a camera. Walks away from. Oh. How long did she stretch?
10 minutes?
Wait, so we're graphing the question or A?
Pretty sure you had some amazing teachers that taught you how to read.
That's the weirdest way of saying that you're stupid. Just read it.
No, it's my way in March of saying I don't need to answer this.
I chose a really awkward scale. I just made 5 boxes. I worked out 5 boxes first, and then it ended up being 2.5 boxes because I had to cut it down. I just wanted to take up most of the screen, really, is what I was trying to do. You can make your scale whatever you feel like. But if you just do 1 mile in 1 box, it's going to be real hard to see what's going on. So if I try to place the point at her start location, well, that's the origin. How long does it take her to reach her friend's house? 20 minutes. How far was it?
Could I please ask Everett to the office?
So the slope of this line, change in y over change in x, right? Change in y
2 miles over 20 minutes. On this graph, what's our slope? 1/10. Right, so this line is, and for now we'll call it y, I guess. Then what do we do?
Just do nothing for 10 minutes.
Do nothing for 10 minutes.
Okay, I'm taking a bathroom break.
No, you said do nothing.
So you're gonna sit there for 10 minutes.
So you don't even breathe.
Walks to bathroom.
Stretches, right? Time elapses. Time, our independent variable, right, is pretty much always doing its own thing. And then how long does it take us to get home?
1 mile is 12 minutes and 24.
Ooh, 24 minutes. So instead of just going to 50, I'm going to end up at 54. So this would be 60.
He wasn't ready.
Now again, let's do our change in y. Okay, 2 miles. Change in x, 24 minutes. Don't overthink this, right? We could use points, we could do subtractions, or we know, like we can calculate how long these individual things took. This is 1/12. So now as we try to write the actual function, the distance related to time. Anyone want to take a go at it? And you want to order your functions by their domain sections. So don't start with the rightmost function. You would want to start with the leftmost
1
function.
and 10x, and then x is less than or equal to 20.
Ooh, yeah. So we can actually, since our domain starts at 0, we need to talk about that because there is no negative time here. So 0 less than or equal to, because that point does exist. Well, I can't use t and then use x. I either need to use t or use x. X? Okay, then I'm switching my t to x. Your input variable has to agree. So x, and then less than or equal to 20.
I think it could be like 0x.
What does the function equal in that range?
No, wait, yeah, you're right. It would equal to.
So this just becomes straight up 2 between the 20. Now this is where people often get confused. One of these has to own the point. So since I made this one own that point, to pass the vertical line test, this one can't also own the point.
Matter which one owns it?
Not okay, so yes, if you want the true answer. In this case, not really, but what you would be arguing is if she's still running at minute 20 or has she stopped.
Doesn't matter.
She runs for 20 minutes. So to me, that goes like through, it doesn't really matter. Not in this case. Now, there are cases where it does matter, right? Like when something's operating or not. And if it jumps location, then it matters, but it doesn't. So especially if this jumped here, which I don't know how it would, unless you got in a car. Yeah, she would have to teleport. Really, the only way this graph could jump is if she teleported. Yes.
Wouldn't the second symbol be less than or equal?
It could be.
Back in time.
Or, hey, great question from Nitin. He said, wouldn't this be less than or equal to? I said, yeah, it could be. Or if we give it to this function, then it doesn't have the or equal here. And here, it's up to you. You're kind of
It
choosing.
could run longer. It's not that much.
So then what is this function?
Doesn't it need to be negative 12?
Yeah.
Ooh.
Because it goes down, or is it just...
Is it negative 12x?
112.
Negative
Like,
112.
Passive and insane.
So we found this slope of 1/12, but it's not positive, it's negative. Right? So be careful as you change behaviors. So guys, this, and we're running out of time, and today's kind of loose, and probably mainly me. Does this make sense for how we iterate or like write out what this function? Because it's one function.
That makes sense.
Right? It's her location. So you have to pass the vertical line test, and that's why these less than or equal to's become important. If two of them own the point, you're no longer a function because you don't pass the DLT. And you're done. That's too fast of a wait time.
Oh, we only have one more.
If you become a teacher, make sure your wait time is 103.
I don't trust
I
any
feel
of
like
these people to educate the future youth. of-
Sorry, I didn't trust me to educate the future youth. When I was your age, I still had in front of me building a potato cannon and burning half of my face. So, if we're going to talk about who trusts who, I don't know that, like, you can't judge your future self on 8th grade self.
Yeah,
This is
yeah.
not- It wasn't my fault, it was my sister's boyfriend. He just wanted to win me over.
Wait, what? Your sister's boyfriend wanted to date you?
No, he wanted to win me over, so he was like, hey, do you want to build a potato cannon? Like, he wanted me to like him, right? Because if you don't like your, whoever your sister or brother's dating, you can work against them.
Yeah.
Right? Be like,
If
hey,
the siblings don't like them, then siblings.
right. Hey, I heard this thing about Ryan or whatever.
I want to make a potato.
Which now, actually, funny enough, that guy who helped me build a potato cannon now owns a campgrounds, like a KOA. So I kind of want to go take my potato cannon out to the KOA and be like, hey, Ryan, remember this? All right. If you think I got rid of the thing that burned my face, you're extremely wrong. Mr. Billings has 4 teenage children. God help Mr. Billings.
Wait, he has a swimming pool, a big lawn, and a large garden house with children?
He's got 4 kids. He's got to have all these
This
things.
horrible.
No, it made it seem
Yes,
like those
I
were
know.
children.
It's the Oxford comma use versus a semicolon or something like that. If they used a semicolon there, then his children would be a pool, a lawn.
And his car, my car.
pools, a lawn, and a large garden.
I mean, I have dogs.
It's
as
like
my
those
children.
people who like call their cars, there's like,
Are we? Every month, he pays a base fee of $37.78, and then he gets billed for how much he uses. This is true. It's called service fees, just to have access to the gas or water or electric. You just have to pay a baseline fee and then charge it for what you use. It's a bunch of nonsense. Seriously, if you go vacation for a month and you don't use any water, you still have to pay like a bunch of money for water because you were hooked up and had access.
Just ask them to turn off your water.
You can. Yeah, if you're going to be gone for a long time, you can have them come shut off your service. So, here's his billing rate. And guys, this is true as well. When you're using electricity or things like that, different rates depending on how much you use. So, you can see what happens to the rate as he uses more. The rate actually increases, right? So this is one of those situations, they don't want you to use more, they want you to conserve. So in between 0 and 8, I pay that
Zoe
rate.
and Alex, please come to the office.
So this is where the misconception will happen. My rate for the first 8 is always $364, no matter how much I use. Then my rate changes to $408 between the 8th and the 24th HCF. Then my rate goes up to $582 between 24 and 36, and then anything over that I'm billed $819 because I'm using an excessive amount.
You're just
Right.
like running all the
Right. So I forget what HCF actually stands for. 100 cubic feet. So their volume of water is being measured by 100 cubic feet. So I mean, think legitimately about a gallon. Like think about a gallon of milk compared to a cubic foot. It's close, but I bet.
gallon is not close to a cubic foot.
Well, so you can see it takes 7 gallons, 7.5 to make a cubic foot. Right. So close being relative, but it's like I was just thinking measurements, like mental and like imagining. So yeah, you need 7 gallons per cubic foot. You're fine. You're right. It's not that close. All right. So they did not use much water in December because they stayed with relatives. So they used 10 HCF. Let's figure out their bill. So really what it comes down to is we should graph this situation.
Can't you just like make it 4?
What's their base that they have to pay?
3778. So if we go to graph this, let's not even think about what the function is right now.
It would be 40 and 80 cents.
But we want to be able to do this multiple times over. So I don't want to redo the math every time I want to do another one of these problems.
I don't want to.
Salty, you don't get.
Okay, I promise. These things are so hard.
If we want to make life easy, we've got like 8, 24, 36. I could make my scale go by 4s.
Right? If we just look at the numbers and what our scale could go by to make life easy.
And then just only fill in the 8s.
Yeah, actually, I'm going to go 4, 8, 12, 16, 24. That won't be enough. I got to go 8 there.
4, 8, 12, 16.
I'm right on.
36.
Well, at least you have to show over 36. So you need to go beyond that.
Draw an arrow.
Right, but your graph has to be able to show beyond 36. You can't just cut your graph at 36. You won't see the next line then.
I'm cutting it.
So 3778 is our initial, which I'm just going to break my graph. Actually, yeah, but I don't want to put it right there. How do we want to make our graph go dollar-wise? What's a standard electric bill end up like max dollar amount? Well, if we read on in the problem, up to $200 I see.
You started at 20. Started at 35.
Yeah, but I'm trying to figure out how high we should go, like how far up. So here they say less than 200. So if I go like 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, I can fit 20. So if I go 20 each, right? 2, 4, 6, 8. This would be 100. And then 2, 4, 6, 8. This would be 200. Always think through that process as when you're making your graph and you're choosing scales. Now this seems to be a perfectly good point to pause and pick this up tomorrow. Thank you guys very much. Have a wonderful rest of your Monday.
Talk more on.
What, wonderful Monday?
Yeah, come on.
Wait, Cat doesn't.
You can have a wonderful Monday.
No, you
Every 3 days.
Actually, no. Garfield
Has a
doesn't.
wonderful Monday.
Garfield doesn't. Garfield is a cat that doesn't have a job. Therefore, there's no difference between a normal Sunday and a normal Saturday, except for that John has to go for a job. Garfield loves John. He's too afraid to admit it.
That's why he
He,
doesn't like
he only
Monday.
loves
Yeah.
John because
Okay.
he supplies him with lasagna.
Okay. I don't know what you want me to say about
You gotta
this.
look up those like
That's
crappy
the only
cartoon
reason
cartoons
Garfield
that are like
loves
Garfield,
John.
you need them.
Because lasagna?
He gives him food.
Okay.